All right, everybody, I'm going to try to kind of quickly run through some solutions to some homework problems that we didn't get to in class. One of them was number 29. So the function was f of x equals 2 sine x plus sine of 2x on the interval from 0 to 2 pi. It asked you to determine where the function was concave up or concave down, and also asked you to find points of inflection. So you're actually going to have to use a calculator for this one, I believe. But let's go ahead and start it out. So we need to first find the first derivative. Okay, so the derivative of 2 sine is 2 cosine and x. And then the derivative of sine of 2x, this is going to be a chain rule situation. So the derivative of the outside is going to be cosine. The derivative of the inside is 2x. And then we have to do times 2 because of chain rule. And then to find the second derivative, I'm going to take the derivative of each of these. So this first one is going to become negative 2 sine x, since the derivative of cosine is negative sine. And this one, I could just put that 2 in front right there. Let's see. Move that a little bit. Okay, so put that 2 in the front there. And so that becomes, just going to put in parentheses. So that's 2 cosine of 2x. So I'm going to have to do the chain rule. And there's a 2 in the front, so I'm going to leave that 2. It'll be negative 2 sine of 2x. And then I have to do the derivative of the inside, so times another 2. So we have negative 2 sine x. And then minus 4 sine of 2x. That's my second derivative. And if I set this equal to 0. So it's kind of looking like this is going to be a calculator question anyway. So you're going to need to like graph this and then just see where it hits 0. So you would graph it in your graphing calculator and see where it hits 0. That happens at 0, which makes sense. That one's kind of obvious. And then the other ones is at 1.823. And then at pi, which also should be obvious since the sign of pi is 0. And also at 4.460. So again, I would have just like graphed that in my calculator and found where it hit 0. So I've got 0, 1.823, pi, and 4.46 as kind of my critical numbers, and I'm plugging it into f double prime to see if it is negative or positive. Okay, so if I plug in any negative number, so let's imagine that I plug in, oh, you know what, it was just going from 0 to pi. So let's see. Yeah, so actually I don't really care about this interval right there. I'm just going to scratch it out because my original function, like in the directions it said, we're just going from 0 to 2 pi. So I don't really care about before 0. Between 0 and 1.8, I could plug in something like pi over 6. That should work. So I'm kind of imagining plugging pi over 6 into this function right here. And notice when I plug it into x, it's just pi over 6, so that's a half. And I plug it in here, it's going to be 2 times pi over 6, so it's going to be pi over 3. But basically, I end up getting like, this is a positive number and this is a positive number, and they're fractions, so I have a negative minus a negative. So I'm going to end up getting a negative number. If I plug in a number between 1.8 and pi, so I think pi over 2 would be an easy one. Because if I plug in pi over 2, if I plug in pi over 2 into this x, that sign of that is 1, so I'm going to have negative 2. if I plug in pi over 2 here, this is actually going to end up, like 2 times pi over 2 is pi. So that's 0, so that just ends up going away. And let's see, I think I did something wrong because I got a negative. Hold on. Okay, I should not have plugged in pi over 2. Pi over 2 is actually less than 1.8, so that doesn't make sense. So I need to plug in something that is bigger than that. So I'm going to just say 5 pi over 6. So if I plug in 5 pi over 6, that's just before pi. I am going to get, if I plug 5 pi over 6 into this x right here, that is a half, and so I'm going to end up with a negative 2. And if I plug in 5 pi over 6 over here, it's going to end up turning into 10 pi over 6 when I multiply it by 2, which is actually 5 pi over 3. And the sign of 5 pi over 3 is negative square root of 3 over 2. So this becomes a negative number. And then a negative times the negative is a positive. And that's going to be bigger than negative 2. So I'm going to end up with a positive right there. Now let's plug in something that's between pi and 4.4. Let's see, 3 pi over 2 would work for that. So if I imagine plugging in 3 pi over 2 into there, Honey, that's my dog, Honey. If we plug in 3 pi over 2, I'm going to get, let's see, this value right here is going to become negative 1, so this is going to end up being a positive 2. But then if I plug 3 pi over 2 in here, this is going to end up being 3 pi, and the sign of 3 pi is 0. Sorry, I'm slightly distracted. 3 pi over 2 does work to plug in, but that's in this interval over here. So I'm going to keep moving forward because I already started explaining plugging in 3 pi over 2. So I have a positive 2 minus a 0, so that means this interval over here is going to be positive. So then I need something between pi and 4.46. So I would be tempted to use maybe like 7 pi over 6. And actually, I was thinking this is going to be this has got to be a calculator question because of these decimals. So you really could just like make sure you're in radian mode and you can type the radians in. You could type in even decimals into your x's and see what happens. So when I plug in something like 7 pi over 6, I end up getting negative. Okay, so here's my sign chart, but that doesn't actually it's not justification or anything. So you just need to explain f of x and be clear about what you're talking about. Don't just say it is concave up. You need to say like f of x is concave up on 1.823 to pi and 4.460. And remember, we're ending at 2 pi. So 2 pi would be the biggest that it could be. And then f of x is concave down on 0 to 1.823 and pi to 4.460. It also asks you to determine the points of inflection. So again, this would have to be a calculator question, but please remember always if you're trying to find a point, you need to plug your x values into the original function, not any of the derivatives, but like the actual original function. So if you were to take, obviously it changes directions. The function changes concavity at 1.823 pi and 4.60. And so if you plug all of those into the original equation, that will give you your actual points of inflection. And those are going to be, so points of inflection are going to be 1.823, comma 1.452. And then we'll plug in pi and get 0. And plug in 4.460 and get negative 1.452. Notice the 3 decimal places always. I would actually really like to talk about number 50 in class. I think it's a good question for discussion. And so I went ahead and just, here are the answers. But so you can check your answers if you weren't able to, but I would really like to talk about this. So we'll talk about this tomorrow. Okay, so number 61 is kind of a doozy because it's like a lot of systems of equations that we're going to be dealing with. So I'm going to do my best to explain it on here. I feel like I need like a big whiteboard to write it all out. But we have the function, we're trying to solve for a, b, c, d such that these things are met. There's a relative max at 3, 3, a relative min at 5, 1, and a point of inflection at 4, 2. So obviously, like relative mins and relative maxes, we can get information about that from both the first derivative and the second derivative, and the point of inflection is definitely from the second derivative. So let's go ahead and find the first derivative. Remember that a, b, c, and d are constants. They're numbers. So I'm going to have 3ax squared, because remember the a is just a number, it's just staying there. And then 2bx, and then c. That's the first derivative. The second derivative is going to be 6ax plus 2b. All right. So we're going to need to plug in some information. I know a couple of things. Let's see. So again, this is going to be a really intense systems of equations problem because we're finding 4 different unknowns, which essentially means we need 4 different equations. One of the things that I know is these actual points. So if I plug in 3, for example, I should get 3. So I'm going to actually take the original function and plug 3 into it. So that's going to be, so imagine plugging 3 into the x's. That's going to give me 27a and then 9b plus 3c plus d. And we said that that has to equal 3 because the point was 3, 3. So again, if you're confused with what I just did, I took 3 and I plugged it in. Let's see, I took 3 and I plugged it in to here. Here's my lightsaber. There we go. So I took 3 and plugged it into those x's up there. Got that equation. Now I'm going to do the same thing, but I'm going to plug in 5 because I also have the point 5, 1. So f of 5 is the same thing as 125a plus 25b plus 5c plus d, and that, remember that point is 5, 1, so it's going to equal 1. Okay, so this is where I feel like you probably have never had to deal with systems of equations quite this intense, but I could take those 2 equations and combine them, like subtract them, or add them to get, yeah, I could subtract them or add them to get the d's to go away. Sorry, I'm not going to add them. I'm going to subtract them. Basically, that would make the d's go away. So I think I would actually like to do the 125 minus this one just so that my numbers stay positive. So notice I'm just recopying down that equation from above right here, and I'm going to take these 2 and subtract them. And I'm allowed to do that because they, as long as I do it like all the way across. So this is going to end up with giving me 98a plus 16b plus 2c equals -2. And I notice that all of those can be divided by 2. As long as I do it to both sides, that is good. So I'm going to have an equation which is 49a plus 8b plus c equals -1. Okay, so we're going to hold on to that. The reason we did that is because now I have an equation that doesn't involve d. Like we're trying to get rid of as many variables as possible here. Okay, because I know that we have a relative maximum at 3, 3 and a relative minimum at 5, 1. That means that the derivative is going to have to equal 0 at 3. So I'm going to take the derivative function. I'm saying that f of 3 must equal 0. So I'm going to say 3a 3 squared plus 2b times 3 plus c. That gives me 27a plus 6b plus c equals 0. Notice that this equation is now an equation that has 3 variables, kind of like the last one. So I'm probably going to end up using that, like those two together. They kind of match. The other thing that I know is that there's a point of inflection at 4. Yeah, point of inflection at 4. So point of inflections happen when the second derivative equals 0. So f double prime of 4 must be 0. And so I'm going to plug in 4 into my x. Okay, and that has to equal 0. So I get 24a plus 2b equals 0. And that's probably something we're going to use, but can't really use it yet. Let's go, and there's more equations that we could create, but I think that we have enough here. So this equation and this equation that I'm putting stars next to, those are the ones that have 3 variables. So if I can combine them in such a way that I get an equation that only has 2 variables, it will make my life better. So I'm going to do kind of like I did with that first one, where if I subtract the 2 equations, then my c's are going to go away, which is helpful. Okay, so I'm taking those 2 equations that I just put stars by, and I'm going to subtract. You have to make sure you subtract everything all the way across. So this is going to end up being 22a plus 2b equals -1. The c's go away. Okay, so now I have this equation, which I'm going to put I'm going to put 2 stars by, and this equation that I'm putting 2 stars by, and they both only have 2 variables. So now this is like, yay, great. I actually have dealt with this before in other classes, 2 equations with 2 variables. So let's write them together. (24a plus 2b equals 0). And 22a plus 2b equals -1. All of these have worked out really nicely to do elimination with. We could do substitution, but elimination is so much easier. I'm going to subtract all the way across. So this ends up giving me 2a, and then my b's end up canceling, and then that -1 ends up becoming a +1. So I got 2a equals 1, so I found out that a equals 1/2. Now that I know that a equals 1/2, I can take it and plug it into either of the equations up here and figure out what b is. So let me do that. This is 12, 2b equals 0. I'll subtract 12, I'll divide by 2, so b equals -6. Checking the answers and making sure that I'm right. Yep. Okay, so now I have a and now I have b, so that means that I can go up to one of my equations that has a, b, and c in it and plug those in so that I can figure out what c is. So I'm kind of like working my way back up. It does not matter which one I pick. Let's see. Let's do, sorry, trying to figure this thing out. Okay. Let's do the one that says 27a. So 27 times 1/2 plus 6 times -6 plus c equals 0. This is not the prettiest, but I'm just going to leave that as 27 over 2 plus 36 plus c equals 0. 27 over 2. I almost missed. This should be a minus sign right there because it was times a negative. So I have 27 over 2 minus 72 over 2 plus c equals 0. and I end up getting negative 45 over 2 plus c equals 0. So c is 45 over 2. Gross. Okay, all that's left is to find d, so I need to go all the way back to the beginning to find d. So if I go back to the beginning, one of my equations that had d in it was 27a, which I'll plug in a half, plus 9b, plug in negative 6, plus 3c, which is 45 over 2, plus d equals 3. Oh man, this is gross. Okay, so I'm gonna do it though. I'm gonna follow through here. So 27 over 2, negative 54, 135 over 2, I think, hopefully. Plus d equals 3. If I make that negative 54 be over 2, so that way they can all, be over 2, that's going to be negative 108 over 2, plus 135 over 2, plus d equals 3. Okay, so this is going to end up giving me 54 over 2 plus d equals 3. Thankfully, 54 over 2 is something nice, which is 27. So 27 plus d equals 3, so d equals negative 24. So I just found A, B, C, and D. It was kind of horrendous. And it is, like the actual function, if I was writing the whole function out then, would be 1/2 x cubed minus 6x squared plus 45 over 2x minus 24. That would be the actual function. So I know in the AP exam they do like questions where you have to do systems of equations, but I feel like this is kind of ridiculous. You were not going to see something like this on one of our tests, and I feel fairly certain you would not see something this intense on the AP exam as far as the system goes. But that's not to say that you wouldn't be asked questions where you have to find missing variables when you're given points like that. Just probably not quite that bad.